All right.
Well, here it's time once again for the fun video games.
Okay, today we are going to
Look at other forms of
graph.
equations and learning about the graphs of the cosecant and secant functions.
Okay.
Okay, so the first thing to look at is the last function that we did last class, we graphed h of t equals 2 times the cosine of t. All right, so what we're going to do right now is sketch the graph of that. Now we've already got our coordinates graphed. This is just a recap from last class. So we are going to look at this and want to talk to you about the equations and what we see in the equation. Notice that if our starting point is at the vertical axis at the point 0, 2, then what we're looking at is a maximum. So we're starting, I use the start in quotation marks, we're starting at a maximum, and the function that starts at a maximum is the cosine function. And notice we are at a height of 2 instead of 1. 2 units above our zeros and 2 units below the zeros. That means that coefficient in front of cosine is 2, and that confirms our equation given. And so one way to label this graph is the given function h of t equals 2 times the cosine of t. All right, let's go to the next slide, and then we're going to come back to this one. Okay, so for instance, if we let the equation be defined by the point t equals negative pi over 2, well, let's go back to our graph there. Okay, let's go to negative pi over 2. Okay, if we start right there, what kind of function starts here at a 0? Well, not the cosine, but the sine function. And notice that if our starting point is at negative pi over 2, we're starting at a 0 and then going to a maximum. So this is a basic sine graph. Okay, and once again, what are we going to? A high of 2 and a low of negative 2. So once again, we still have the coefficient of positive 2 in front of the sine function. We have shifted our graph. Our 0 is now shifted to the left, so that makes the t plus pi over 2. And so we would label this maybe g of t equals 2 sine of t plus pi over 2. Okay, let's go back to the next slide again. Now let's look at the next bullet point. What would happen if we started at pi over 2? So let's go back to our graph and have a look at that one. And starting at pi over 2, okay, what's happened here? Well, we've shifted to the right, so that's going to mean t minus pi over 2 in our parentheses. But what else? Let's see. So let's build it. T minus pi over 2, that's going to be in the parentheses. Now what function? Is it sine or cosine?
Well, since it's starting at 0, I would say sine.
Okay, because sine starts at 0. Oh, see how stupid that is?
But you can see, since it's going down, we're going to have a negative. It's going to be a negative, and since the height is 2, it's going to be minus 2.
Okay, so our coefficient is negative 2. Negative because we're starting at a 0, but we're going to a minimum. We're decreasing, so that's a negative. And then the coefficient of 2 because instead of going to 1 and negative 1, we're going to 2 and negative 2. We're going 2 above and 2 below the zeros. So we'd call that, I don't know, g of t equals that. Okay, now let's go back one more time. What would the equation be?
Oh, maybe we should write that. There, let's see.
Oh yeah, let's write it. So g of t equals negative 2 sine parentheses t minus pi over 2. Okay, now what we want you to do is look at that graph that you have in front of you and take a minute and see if we started at pi, where would we be? Okay, so we're going to give you a minute to think about it. We're going to start at pi. So when t is equal to pi, find that point and give yourself a few seconds to figure out what that equation would be.
All right. So here we have pi.
Well, we're not starting at a 0. We're starting at a minimum.
Which is cosine starts at maximums. But if I use the negative cosine, it would start at a minimum. So I know that it's a -2 cosine graph because it's cosine starting at a minimum, so it's negative, with a height of 2, so that would be the 2. And since I shifted it over pi, it would be t minus pi.
Because pi is a shift to the right. Okay, and so let's just call this g of t equals -2 cosine t minus pi. Hopefully you came up with that before we gave it to you. G of t equals -2 cosine of parentheses t minus pi, close parentheses. All right, so what we know is horizontal shift. That's also, by the way, the word given that we use a lot is called a phase shift. A phase shift is the same as horizontal shift. A horizontal shift occurs when there is a number added to or subtracted from the variable inside of your parentheses, okay? Just like a shift of pi to the right, t minus pi, okay? Because if we substituted pi in for that t, it would give us a 0 inside the parentheses. And when there's a vertical shift, we add or subtract outside or after the function, okay? Outside of the parentheses. So note that it is very important to indicate your horizontal and vertical shifts by your dotted lines. You'll notice that Mrs. Meller did the dotted lines on her graph whenever she was indicating a shift. That is very, very important, okay? All right. So let's continue. Notice we're doing this on the smart board in conjunction.
If
All right,
you
well,
can hear the banging in the
banging.
background,
That's
that's what's going on.
So here we have a new word. It's called amplitude. We actually have used the amplitude the whole time. We just haven't used that word. The amplitude is the coefficient of the sine function or the cosine function. It's your coefficient, okay? And so when we talk about amplitude for the cosine and sine functions, our maximum value is 1. Our minimum value is -1, of course, unless we change what we're multiplying by. And the amplitude can be found by taking 1/2 of the maximum minus the minimum. Okay? Notice, amplitude, since you're always taking a bigger number and subtracting a smaller number, amplitude is always positive. Now, it's always a positive number. Okay, so if we look at amplitude, it is the absolute value of a. So when we look at our function f of t equals a sine of t, or f of t equals a cosine of t, that a in front is both a coefficient and it indicates our amplitude. So if we look at problem number 1, notice that a is -1/3, but our amplitude is the absolute value of a, and that's positive 1/3. Now what this means though, guys, is from your zeros, your maximums and your minimums will be 1/3 above the 0 and below the 0. Let's look at problem number 2. Problem number 2, what is our coefficient of the function?
That would be a 1.
So a is 1, and guess what? That's already positive. The amplitude is also 1. What that means is your maximums and your minimums will be 1 unit above and below where your zeros are. Okay? All right, so now we are going to turn our attention to graphing the cosecant and secant graphs. All right? Secant and cosecant are reciprocals of the cosine and sine functions respectively. For instance, we know that if we have the sine of pi over 6, we know that the sine is 1/2. The cosecant would be the reciprocal of that, which is 2. If the cosine is 0.1, you should recognize that 0.1 is 1/10. So the secant is the reciprocal of that, which is 10, and so forth. Furthermore, we have an additional issue. Sine and cosine both have values of 0. So when the sine function has a value of 0, the cosecant will be undefined. And how do we show undefined? Well, it's called
An asymptote.
yay, our vertical asymptotes that we've used for various things all year long. We used vertical asymptote with our logarithmic functions, and we used them in radii. Guess what? It has the same meaning here. So when we graph the cosecant and the secant function, it is going to depend on what's really going on with your sine graph and your cosine graph. All right? So that is what we're going to do. We're going to graph the sine first, and then we're going to use attributes from our sine function to graph the cosecant. Here we go.
All right, so we're going to graph the cosecant. which is the reciprocal of the sine graph. So first we're going to graph the regular sine graph.
And we're going to do that in a dotted form because it is, we're going to use information from that graph. Okay, so notice that to graph a sine function, we discovered in the last class that all we needed is those critical points. And remember, critical points are zeros, maximums, and minimums. Okay, so here comes our sine graph. Now, in the last class, we talked about where a function was increasing and decreasing. That's going to matter in a little bit. But let's find all the places where our function is 0. Okay? All of the zeros, what are our zeros going to give us?
An asymptote.
The reciprocal of 0 is a 0 in the denominator. So that's undefined. So we're going to have vertical asymptotes everywhere that we have a 0 on the sine graph. So we're going to sketch those in very nicely. Okay, these are kind of dashed and not dotted. These are actually part of what we're using for the cosecant graph. Okay, now here's the cool thing. We're going to reciprocate all the values.
All right, 1/2 is going to be,
which happens at pi over 6,
is now going to be 2. And 1/2, which happens at 5 pi over 6, is also going to be a 2.
Okay, so that point is going to come up here, and notice that here the reciprocal of 1 is still 1.
So it stays where it is. And the smaller the fraction gets, the bigger the reciprocal is. So like, for example, if I had a value of 1/6 down here close to here, that like 1/6 is my sine, then my cosecant would be 6, which is like way up here, okay? So the smaller the fraction, the bigger the reciprocal.
And now another thing to notice as we're looking at this, notice that where this function, the sine function, is increasing, notice that the cosecant is decreasing. Where the sine function is decreasing, the cosecant is increasing. Now I have a question, Mrs. Miller. Have we graphed a whole cycle of cosecant?
No, we have not.
How come?
Because we have not covered the situation, the scenario where, from pi to 2 pi. Since sine has a period of 2 pi, cosecant as well has a period of 2 pi.
So look what's happening. Look at our sine values from pi to 2 pi. Those are all negative. So guess what? Cosecant values will also be negative. And now you get a general idea of how it looks. Okay, now some of you are going to go, oh, that's just a parabola. It's really not a parabola because it's not formed the same way, but if you want to think about that it kind of sort of looks like one, it kind of sort of does. Now let's go ahead and, these are called branches. We have 2 branches of our cosecant graph that make a complete cycle. We have a concave up and a concave down. And we're going to just go ahead and do the other 2 parts since we were asked to sketch the graph from negative 2 pi to 2 pi. Now do you see how easy that is? Again, notice that the trick is to sketch your sine function first. Also notice that what the actual graph is just the vertical asymptotes and the actual branches of the graph. Do you see that? So that's really important.
So when I moved the green stuff so you can see what the graph actually looks like, okay? I'm going to put them back so that we can see how we created the graph. Now on your paper, we expect to see that sine sketched in.
Yeah. Yeah, we expect to see this. I don't know how to move that. Oh, I moved the wrong thing. Here we go. Move the thing a little bit better. Okay.
Where are you going to move?
Oh, whatever. I was just going to put it on 0. It's fine. It's good. All right, next. We're going to now graph negative cosecant of t.
Negative 2.
Negative 2. Okay, so let's first of all write the basic function we want to start with, which is what?
Negative 2 sine.
So let's write that out. We're going to take f of t as our parent function, and it's going to be negative 2 sine of t. And so negative 2 sine of t. Sine starts at a 0, and if the coefficient is negative, it's going to go 0 and then down. And our amplitude is 2, so it's going to go 2 units above and 2 units below the 0. Okay? So here we go. We're making a beautiful graph. And we're going to dot this in because we're going to use the information from this one to graph the actual cosecant. Okay, here's what we start with. Everywhere there's a 0, we're going to put in a vertical asymptote. Go for it. And now you ought to be able to draw in every single branch. Where the sine values are negative, your cosecant values will also be negative. Where your sine values are positive, because a reciprocal of a negative is still negative. A reciprocal of a positive is still positive. Okay? So you should be able to sketch all of these in pretty easily. Now, here's what's interesting. Do you notice that your value for cosecant is never 0? What is the ratio for cosecant?
1 over...
Yeah, but it's also r over y, right?
Oh, yeah.
The cosecant ratio is the reciprocal of sine. Sine is y over r. Cosecant is r over y. And remember that r is always greater than or equal to your y coordinate. So it can never be 0. Your cosecant can never be 0 unless we've shifted our graph vertically. Okay? And now you are going to graph this one.
All right.
Okay, so now we're going to graph cosecant, and guess what? Cosecant, not cosecant. Secant is the reciprocal of cosine. So what we're going to do is quickly sketch a cosine graph.
Right, so cosine starts at 1.
Starts at a max and then goes down to a 0 and then a minimum. Everywhere you have a 0, we're now going to have a vertical asymptote because the reciprocal of 0 is undefined.
You might say, but they look so much alike. It's true.
Yeah. Remember at the very beginning that we had a graph and we could label it as a sine or a cosine graph depending on where we started? A cosine graph is really just a shift of the sine graph that's just been shifted over. Okay? So that's true. They do look alike. Look at that.
Because remember, cosine and sine are
co-functions. Mm-hmm. And a co-function just means it's going to have the same value at the complementary angle. Okay, there is secant of t. All right, let's do the next one. Oh yeah, I forgot. I wanted to talk about this. Notice that for both functions, there's no values between -1 and 1. This is on the basic graph. Notice that they have vertical asymptotes. And again, since our basic function has a period of 2 pi, it is your critical points are found every period over 4 units, or pi over 2 in this case. And one cycle consists of 2 branches, one that's concave up like a cup, the other down like a frown. Go back to the previous graph real quick. Notice that here, this is for secant, and it would be the same for cosecant. But notice that our values for secant are between 1, or are from +1 to infinity, or from -infinity up to 1. Okay? So there are no values for secant in the basic graph between 1 and -1. Okay? So our range is 1 to infinity or -infinity up to and including 1.
Well, one thing I wanted to mention was I accidentally added too much of the graph. It says that you want to graph the interval from -2 pi to 2 pi, and I accidentally graphed past 2 pi. If we indicate where we want you to graph, we don't want you graphing any more of it than that. Okay, so that's why I erased the the other part of the curve.
Also, let's look at a few things that you should be tying together. Notice from 0 to pi over 2. This is quadrant 1 angles. Notice cosine is positive in quadrant 1. From pi over 2 to pi, that is quadrant 2. Notice that in quadrant 2, cosine has negative values. From pi to 3 pi over 2, those represent quadrant 3 angles. Notice your cosine values are still negative. And then from 3 pi over 2 to 2 pi, you're looking at quadrant 4, where the cosine values are positive. So all of this is relating back to our unit circle, where we have all of our coordinates, where we have positive, positive here, and here is positive, negative. Okay, all of these things are very important. They all relate, and it's important that you tie this together. Okay.
All right, so now we're going to graph 2 secant t plus 1. But our function that we're coming from is 2 cosine plus 1, 2 cosine of t plus 1. So I'm going to graph f of t equals 2 cosine of t plus 1. The first...
Yeah, we have a few things. Do we have a horizontal shift?
No.
But we do have
a vertical shift.
So we want to sketch that in first. Again, do that with a dotted line. This represents what's called the sinusoidal axis. Sine and cosine are called sinusoids. That's what they are. They're sinusoidal functions, and that is a shift at the axis. Now we're going to look at our amplitude. A is 2. The absolute value of that is 2. And so from our sinusoidal axis, our zeros are going to occur on our sinusoidal axis. So from our sinusoidal axis, we will go a 2 above and 2 below it.
Which is not 2 and negative 2. That would be 3 and negative 1.
Yeah, we're going to go 2 units above our sinusoidal axis and 2 units below. Sinusoidal axis is where your zeros are occurring. Now notice, if you look at the dotted line there, that's not where the y-coordinate is 0, but we have shifted the graph up, so this is our new zeros. Okay, it's not where the function itself equals 0, but it is where the zeros on that horizontal shifted axis is. Okay, so here we are looking at the 2 times the cosine of, blinking. We're doing this on the smartboard, which is currently blinking. So in a minute, we'll be able to complete it.
Okay.
There we go.
Okay, is it good now?
Yep. For some reason, these boards just decide to blink every once in a while. All right, so here we go with the 2 cosine of t. And now, notice that we are going to, everywhere that there's a 0 on the sinusoidal axis is going to be our vertical asymptote. Okay, and once again, everywhere where this function is increasing, the reciprocal will decrease. Everywhere where the function is decreasing, the reciprocal will increase, and so forth. Once you have the basic function, you can certainly draw the branches easily.
All right. Now this one didn't say negative 2 pi to 2 pi, but I'm just going to do it just for grins.
Because that's what our graph was. Okay, if you can sketch this one, please, we would appreciate it.
All right. That's the end of the video. So to confirm that you have watched the video, by 8 a.m. on the day you have class, email us with 1 new thing you learned, 1 good question, 2 old skills that are important to recall, and don't forget to bring your entrance ticket problems, i.e. these 2 problems, and the completed notes, and round 2.
That's right, round 2. Also, make sure that your graphs are neat. The 2 that you have had to sketch as your entrance ticket, make them neat. The axes should be labeled properly.
Yes.
That's it. Thank you.
Bye.